Professor Black Ops. You see it. Let's get it. Linux malware. It's becoming more common, right? Because a lot of cloud runs on Linux, so a lot of great things run on Linux. So much more malware for that, and I think nation states will get and hackers are just getting better at it. So once again, let's check it out. So let's just kind of walk through at a high level what that would look like. They had a diagram in the article, so let's kind of walk through the diagram before we get into the article. So you have your infected computer at the top, command and control. You download and execute it in memory, the Metasploit. Then the second stage, it's a good thing because it's a two-stage malware. That makes it a little difficult for virus protection and malware software to catch it, right? So second stage dropper, bit spin F file, decrypt and execute the shell script. When we go through the article, we're just going to highlight a few of that inside the code and see what makes it a little different, right? These are the two CVEs, 2021 4034 and 304093. Once again, to the command and control server. Third stage dropper, decrypt and execute the shell. Then the final payload is what gets loaded on there to start encrypting and messing your computer up. Basically, you got a Unix shell script, BRIHC script, pull trick truck and restrict, and a standard SSHD for a crypto miner, right? So you can actually encrypt it or run mining software on it to try to get a little money. So that's what the article is going to hit. And at the bottom you see it was done by AT&T security team. So shout out to them. They putting in great work. So once again, let's hit the article. You see it right there. New Linux malware evades detection using the multi-stage deployment. That's what we're looking at right in the diagram, which is in the article. It's multi-stage. Makes it a little difficult to find, right? New stealthy Linux malware known as Shikitega has discovered infected computers and IoT devices with additional payloads. The malware exploited vulnerabilities to elevate its privileges, add persistence on the host via crontab, and eventually launched the crypto miner on effective devices, right? So crontab is basically just a Unix scheduler. We have to be careful with it because I see a lot of cron tabs running as root or some high privileged account, right? In case the scripts need to do advanced features. But if the malware gets executed on a cron tab, right, it's going to have the same privileges as the cron tab. So Shikita is quite stealthy, managing to evade antivirus detection using the polymorphic encoder that makes static and signature-based detection impossible. An intricate infection chain. While the initial infection method is not known at this time, researchers at AT&T who discovered it said malware uses a multi-step infection chain where each layer delivers only a few hundred bytes, activating a simple module, then moving to the next one. The malware is delivered in a sophisticated way, uses a polymorphic encoder, and gradually delivers its payload where each step reveals only part of the total payload. The infection begins at 370 byte F file, which is the dropper containing the encoded shell code. So that shows you it. The cool thing about it is it's only 376 bytes, right? And that's the malicious shell code right there in red/purple. I think that's red with blue is purple, but that's where it is, right? So that 376 bytes, right, gets in your system to call the command and control, and that's one reason why it's hard to find. The encoder is performed using a polymorphic XOR addictive feedback encoder, previously analyzed by Mandiant. Using the encoder, the malware runs through 7 decode loops, where one loop decodes the next layer until the final payload is decoded and execute. The encoder stud is generated based on a dynamic instruction substitution and dynamic block order. In addition, registers are selected dynamically, right? So when they're dynamic, it's kind of hard for the virus protection of the malware finds, because a lot of times if it's dynamic, it's gonna change, right? So they got stuff in there. So that shows you the first. Then the XOR means, right, it's doing that section, then the second step, right? So once again, it's not one block of code, so the scanner can see this pattern. Since it's done in 2 loops, once again, it makes it a little harder for it to find. After the decryption is completed, the shell code is executed to contact the malware command control server C2 and receives additional shell code commands stored and ran directly from memory. Right, so since it's not on a hard drive, it's in memory. It's hard to detect. A lot of times the pattern is used when it gets the hard drive or it gets passed in there if it's executed in memory. Once again, it's hard to find. One of these command downloads a metal, a small portable metal exploit, an interpreter payload that gives the attacker further remote control and code execute operations on the host. So right there, that's the metal exploit, additional shell code, just that little block right there. That'll be executed in memory, right? So metal fetches yet a smaller F file, which exploits the CV 20214034, which is the pawn kit, and 3493 elevates privileges and downloads the final payload, a cryptocurrency miner as the root, right? So they trying to make money, right? So you can encrypt it, mine it, or do both, right? So that, once again, that's that block of code. It shows you the CV 20214034. So obviously that's been out since 2021. So persistence for the crypto miner's tree by downloading file scripts that add 4 crontabs to the root user and to 2 current users, right? So those are the shell scripts units, the brick we was talking about, polymorphic truck and restrict, and like I said, put it in crontab. All that's running in crontab, right? And crontab's the scheduler, right? So we should be signing programs that we put in scheduler to make sure the scheduler should be able to run them, right? So we got to figure out what that safeguard is in the crontab to make sure we're not running illegitimate programs, right? Crontab as an effective persistent mechanism, so that all downloads files are wiped to reduce the likelihood of malware being discovered. The crypto miner SMRG 416 focused on mining, the anonymity focused on the hard to trace Monero, and that's what we were looking at a minute ago. Command and control, the metal exploit, the F file we looked at. Those are the 2 vulnerabilities. The third stage dropper then pulls down all those shell scripts, then erase them at the end, right, to make sure make it harder to find. To reduce the further chance of raising an alarm on the network security product, the threat actors like Shikitega uses legitimate cloud hosting services to host the commands and control instructions. The choice costs more money, but the operators are at risk of being traced and identified by law enforcement, but offers a better stealthiness in the compromised system. Right? So if your system sees it's coming from Amazon, Azure, Google, or Rackspace, it's going to less likely think it's a virus or malware because it's coming from a legitimate cloud vendor. The AT&T reported a sharp rise in Linux malware this year, advising system admins to apply available security updates, use EDR on endpoints, and take regular backups of most important data. For now, it appears to focus on Monero mining, but the threat actors may decide that other more potent payloads can be more profitable in the long run. So right now they're focusing more on Monero mining than for ransomware, right? But if the Monero mining is not making money, the software is on there. They can just encrypt your hard drive and ask you for ransomware, right? So once again, Professor Black Ops, please subscribe. Shout out to Linux Malware. We got to be careful out here. Got to be careful.